Keep background minimal. Charlie, when you're done,
Yeah, this is a different kind of presentation. Background is minimal. Okay, go.
Okay, so I'm looking at a potential role for endocannabinoid pathway in alcohol CPP using zebrafish. So just a quick background, you're saying CPP is conditioned fit preference, and basically just to get your head around it, if you're basically training an animal to associate a room or a color or something with, in this case, receiving alcohol. So for us, we'd be doing, we have a tank that was divided into sections, and you would have the zebrafish associate one side, let's say it had like blue dots on it, and they received alcohol in that side of the tank for a certain amount of time. Eventually they would learn that that part of the tank associated with alcohol, they go to that part of the tank thinking that they're going to get alcohol. So that's like a really brief idea of what CPP is. It's basically just conditioning an animal to have a preference to a certain place based on, in this case, alcohol. And then the endocannabinoid pathway is a signaling pathway in the brain, and it's kind of been shown, it's in all different places in the brain, but it's been shown to be involved in addiction, and specifically cocaine and nicotine addiction. And usually, mostly because it's associated with memory, and a lot of addiction has to do with memory because...
So you read the CPP paper on the zebrafish, right?
Yeah.
Okay. Do we need any new equipment for the CPP?
No, because we might need like dividers or like stickers and counts and things like that, but not like major.
Does it require the kind of tunnel kind of thing that we were talking about earlier?
Well, there's two different ways to do it.
Yeah.
One way is just like having two dividers that you color brown, or you would take the tanks that they have and then like drill a hole. You would have like two, and they would have mini dividers. So like there's multiple ways to do it.
How many times has this been done? Only those 2 times?
I think it's twice.
Okay. Can you go next?
So you don't want any more background? So, as I said before, we've been doing alcohol CPP with zebrafish, and then after that we dissect zebrafish for the brain, and we basically the overall goal would be to get a receptor called the CB1 receptor, and that's part of the pathway as described before. And if you can detect that protein, if there's a lot of that protein, that's a signal that the endocannabinoid pathway is involved in alcohol preference and alcohol addiction, in this case of zebrafish, because it's been shown that CB1 has been involved in alcohol addiction in mice and in humans, but not in zebrafish yet, because CBP with zebrafish is kind of difficult. So this would, yeah, like she said, this hasn't been done yet in terms of alcohol CBP and CB1 receptor identification. So you'd have RNA extraction PCR, and then qPCR to amplify the CB1 receptor. But you could also amplify the GABA receptor just to practice amplifying.
And you would do amplification of the RNA, non-quantified PCR of the RNA in the beginning, right?
You would amplify. You want to amplify, practice mRNA extraction and amplification before you do qPCR.
Okay. Have you found people who have quantified GABA in zebrafish from RNA?
I haven't read anything, but...
Okay. So we don't have a primer set right now.
No, because that primer set that was emailed was for only mice. I looked at it.
Okay.
Mine was only mice.
The one that Xenia sent?
Yeah. I went on like Bio-Rad and things like that, and it was mouse.
Okay. So I think any bee sells housekeeping gene primers? No. Kyogen.
Maybe.
Kyogen.
I don't know.
Right? That's not what they said?
They said that for the RNA extraction kit.
Right, I think Kyogen also sells,
Well, they sell the RNA extraction kind of kits, right? So,
Yeah.
but I think they also sell primer kits.
no,
Yeah, I have
not.
Alright, so here's the thing. If you're looking for PCR amplification of GABA or CB1 out of genomic fish DNA, just not even dealing with the RNA, that's a month, 2 months.
I mean, you gotta just design some primers and give it a shot. If it's from DNA, it should
from fish DNA, it's uglier.
Yeah.
I don't know what the license kind of protocol entails, but
Okay.
So yeah, that would take a while, but then hopefully, we probably won't get here, but we would want to do the CPP again and have a C1 antagonist to see if we can block the difference that the fish had created, hopefully we'll create. And then in like the way future, this is only testing preference, but it'd be really cool to test self-administration and seeping of alcohol. But that's really hard to do because if you have a tank, you can't really divide the alcohol and the water too easily without it spilling over. But that's like way future. So it wouldn't be done this year.
But the thing is, it's simple. If we can develop a fish self-administration model of alcohol, we're instantly publishable. No one's done it. And it would cost less.
Then if you want to just skip to that as a reason, like theoretically, like it's.
I think the tube idea that we were talking about. So basically, we're trying to figure out how you get a fish to select alcohol. How do you get a fish to drink alcohol?
Because
Choose it.
with CDP, you can like divide a tank so water doesn't spill over because you're putting it in a specific section, but you can't really put a fish in and say like if you choose where the alcohol is because eventually the alcohol like in the water will flow into each
You can't give a fish a water bottle and say
Yeah, and
the
take-
water bottle fill with water and a water bottle
Right.
fill with alcohol and say drink.
But there is the idea of like the really tall tanks because it'll take alcohol longer to travel.
It's a lot less attractive. It's a lot less techy. If we can get there before other people do.
yeah, I mean, it's
So we
certainly
could like test with the big tanks or the really deep tanks to see like how long it takes for the alcohol to travel.
And they will come to, like, they will seek food, right? So maybe you can put a slurry of food in some kind of tube train to go to that, put your alcohol in. Is that what you were thinking?
I think
A couple problems we're running.
Is there a way that you can determine, because I mean, really it's going to be about the time it takes for diffusion
Right.
through the entire solution. Is there a way
Right.
you can detect that?
So not a good one right now. We were trying optical density in the past, but then somebody somewhere has made Jello
Jello shots.
Shots
That could
from
be a
brine
way of
shrimp.
doing seeking because and like associate and make different colors also because certain fish like prefer blue as color.
But there's still problems you run into, like how do you weigh the stuff after it's been in water?
Yeah.
There's a lot of like trial and error before, especially like.
But I mean, if without a good way to measure it, it's hard.
Right.
Granulated alcohol balance.
Those are, I mean, everything's gonna dissolve, right?
If we can find something with a similar, maybe we can find an alcohol reporter, something similar structure and density, that color that we could spec.
Well, you know, you can do, what alcohol percentages in the water are we talking?
What's that?
What alcohol percentages in the water can we talking?
Well, you could do like 0.5%, 1%, or 1.5% actually.
So one and a half is like the high
Yeah.
end.
Which I would like to try.
Yeah.
Just because
Yeah, that's pretty low. I mean,
Yeah.
Yeah.
Right, I mean,
refractometer is the refractometer is the tool that your growers use for detecting.
Oh, to detect.
So,
Do we have one of those?
I'd love to have one.
How much was one of those cost?
I don't know, Google. I remember.
Can somebody Google refractometer real quickly?
I remember it being more than I wanted to spend out of my pocket. So $60 could be this cheap.
Okay. So time to first data and cost to first data.
Well,
So the RNA expression kit that they sent us, I looked at it, it's $289. Timers, if we can get them from Mountain or Costco, but as I said, they're nice. So,
But there's that person, Aaron, did the fish, right?
yeah. Or he did.
She.
It's
the grad student that had done a lot of the fish work, there's like a fish lab at Rockefeller, and the grad student that had done the fish work left like a week before we got there, and apparently nobody knows. Why don't you contact Beth Doherty and then ask her if we can get the contact information for Aaron?
I mean, it sounds to me like doing this like the work with the RNA and all that seems like something, because you guys haven't gotten that really working in the past, right? qPCR and all that.
No, but the problem we've been running into is whole fish homogenization. How do you blend a fish?
Do you need to do the whole fish, or you just do the brain?
Well, the problem is if we do the brain, then we need to do like 6 per sample. Right?
And Zena said that we could just like cut it out for the connections. So I looked at the quantizer, but it was really expensive. Cut it up.
Okay.
And this is like a mini, so then like for the future, I was looking at like different subject practice, but it just depends on how much we order and things like that.
And how much? So how long till we see? We can see gene expression changes in a day, right?
Well, I feel like just getting the CPP working.
I see 3 different experiments here. I see CPP, I see detection of GABA, and I see the new.
Well, there's actually 4 technically.
Okay, what's the 4th?
It's the 2 step.
Right.
Then there's also CPP with the antagonist, so you can block difference.
Right.
There's also CP.
Right, but those are just combinations of the other 2 experiments, right? What I'm saying is you would run 2 of those experiments simultaneously, the CPP and. Okay. What kind of timeline are we talking about? And what kind of people are we talking about?
Because like there's, I had like 1 to 2 of like just people who have gone through at least like freshman bio, because there are certain things that we don't really need like lab experience for in maintenance, and like CPP it's not like a lot of bio, I guess, so that's like someone I can train really easily. But then I would need people who like pipette, PCR, hygiene kits, things like that, or at least one of them I think is enough.
Here's what I suggest you do. I suggest you break this up into the 3 experiments. So the alcohol self-administration, the CPP, and the extraction amplification. And I suggest that you consider taking on a full-on iRT member with molecular experience to help you run, and then see how many underlings that would require you to have.
So one person helping run all 3 or something?
So what I'm saying is you can't run all 3 by yourself. So you dedicate yourself really to the oversight of 1 or 2, and then have someone else, another IRT member that you trust enough to oversee the other one. And then
in that case, that person would be research.
Yeah, what I'm saying is just kind of rework this idea, and then get a timeline. Because we don't need to do 2-week anticipation experiments to get some of this data, right? We just need a lot of fish. Okay. So you're gonna have to rework your people, and you're gonna have to rework your timelines.
Are you going to be breeding fish?
Yeah. But we're 5 weeks out from that, right? 4 weeks out now.
Oh,
Yeah. So make sure you work that into your timeline.
Okay.
The breeding and the
And the
system flush. Okay, thank you. Any questions?